Hey everybody, welcome back to Fastware. So today I have a couple of tips, tricks, and tools for you to use when optimizing your code to understand what's happening, why exactly it's happening, and for what reason, obviously. And today we're going to be looking at a couple of tools that I use and how I use them in order to understand the profile of the application and whatnot. Not going to be going very much in depth with everything because I did videos earlier on some of them as well. So I will leave the links in the description and the cards as I will be talking about it. So you can stop watching this one, go there and check it out. So yeah, so we will start with a Google benchmark. This is my go-to to start with. Obviously, I talked about it earlier, so it's not going to be in depth, but it is a great tool for any micro benchmarks that you want to understand a little piece of code, how it behaves, and what is the performance characteristics of it. This is what I would recommend you to start with. And if you cannot be bothered to do it in your own IDEs or in your own terminals, there is always an online resource. It's called Quick Bench, which you can paste your benchmarking code without the benchmark main, just benchmarks themselves and without the header. And basically you can run it. It will basically benchmark and produce a beautiful output for you to have a look at, as you can see on the screen now. Now, following these two tools, the next best thing is obviously a compiler explorer. So you have probably, I hope that everybody have seen a compiler explorer. The guy who introduced it, Matt Godbolt, a great guy, and had several talks on CppCon, actually explaining in detail how it came to be, what it's all about. So I recommend you to go watch it. The link will be in the description below as well. So, and the compiler explorer is beautiful because it highlights part of the code and you say, okay, so what does that do? You can just right click and say, reveal linked code, and then voila, it basically tells you immediately which assembly is linked to. Now, when it comes to assembly, I'm not saying that you have to be able to write assembly or understand every single bit. But if you're going to be working with performance and trying to improve performance, you need to have some understanding of assembly, of how it works, basic instructions and whatnot. It is really not that hard. You can basically see it's an if and you have a compare and a jump. It's that sort of a thing, and then you have moves, you have instructions, you have you have XORs, you have this is just calculating the address. You have calls, jumps, moves, and more of the same. It's not that complicated. Just if you take a little piece of code and analyze it in detail, it will really reveal how simple that structure is, and give you some good understanding of how your programs are constructed in assembly. So I really recommend to do it. This actually compiler explorer also gives you a whenever you highlight over instruction, gives you exactly the information what this thing does. So as here, copies double word from a source operand, second operand to the destination, which is the first. So everything in great detail, and I really recommend studying it for a little while until you kind of feel semi-confident. Your confidence will grow as more programs you will be analyzing. So again, I will leave to his talk explaining how it works in detail in a description below. Now, next thing that I'm using, I'm a Linux engineer, as you probably know. I always recommend the Perf tool. A Perf tool is a magnificent tool for Linux. It is beautiful. It is capable to give you statistics, about your application. You can record a running profile of your application to see different event counters, such as where the most cache misses have occurred, or data cache misses, or where most of the instruction cache misses have occurred. Branch mispredictions, and all kinds of stuff like that. It is a magnificent tool, so I really recommend to have a look. I have done 2 videos on Perf before and how I use it. The links will be in the description below, so check them out. But if you are programming for Linux, I have no higher praise for any given tool than Perf. It is a bread and butter of a performance engineer tool set. So with that quick introduction out, I would say that I always hear this sort of commentary from other people say, okay, so Perf and benchmark, Google benchmark are great for like a teeny little code. However, they're not great when you have large scale applications and you want to understand their behavior. Well, this is true. So Google benchmark is good for anything that can be unit. So a unit testable function or a bunch of functions which can act as a unit function, you can do with a Google benchmark. But if you want to look at the general profile of the entire application, function per function, you can always roll your own profiling tools, like an ad hoc little thing that you can put in your code. And today I will show a little one of those that I have implemented just to demonstrate that it's really not that hard. So this is my dumb profiler. And I didn't call it dumb because I respect my little profiler. But here it is. As a constructor, it takes a function name, a file name, and a line name. And what it does is just using the chrono namespace implementation for a high precision clock, so high resolution clock right here. I might basically record a time when it started. And then during the structure, when it's running, I will basically take the current time minus the start time. I cast everything to nanoseconds. I grab that duration, and then I'll do some printout. So here I have basically a thread. You probably noticed that I'm not using std threads because std thread, this thread get ID is a sort of a non-castable struct, which is very difficult to print. So I try to avoid doing that. This is just a standard POSIX pthread handle, so I can get that ID and print it. It's just an unsigned long right here. So what we have. And then basically I just print as a little JSON file, JSON object, as you can see. So this is the thread UL file string line long decimal function, and then duration, which is just a measurement to 3 decimal points. That's it. So duration to 3 decimal points. So to help to use such a tool, I usually implement a couple of utility macros. So this is just a kind of a profile. So you will start with profile, which does some magic to concatenate the __perf_ with a counter, which is every time you call it, it just gives you a different integer. So it's going to be starting with perf 0, perf 1, perf 2, perf 2. So, and the reason why I did it, so I could use the same profile in the same function multiple times. So if you have a actual name, so this is, as you can see, profile, and then this appending happens, passing function, file, and line, which are defined, I think, by all compilers, but GCC, Clang for sure. I haven't used MSVC in a decade, so I don't know. Sorry about that. But generally speaking, I want to use this profile in the same function multiple times without hiding the variable, right? If I'll just use __perf, that will basically if I'll introduce twice in the same scope this profile, it will hide one another, and you're probably either gonna have a compiler errors or some other gibberish coming out of it, which you probably don't want. So generating this actual variable name is a great way to overcome this. So, and I will show you how I'm using it in a second. So here is my test function, a little something, do something. It really just nonsense. It doesn't matter what it does. So I just introduce at the top of the scope profile. And then as the scope runs out, so the brace closing the function, so the scope runs out, the destructor for profile will run and will basically print this. Obviously, in production, I would not recommend printing directly to console. You probably want some sort of a high throughput logger, which does not call the system interrupts for every of your profiles, because that will slow down your code immensely. So you probably don't want that. You want some async logger on a side. But this is just a demonstration. From there, you can basically take it wherever you want. And my driver code. So here what I meant that I can have basically profile on the in the same function multiple times and the same scope. So I want to profile the entire thing. I want to basically profile as I'm pausing out the argument, or basically checking if there is an argument and pausing it out with that print. The next thing I want to profile that function call, then printing of the result. Then I want to profile the actual profiler. So see how long it actually takes to construct and destruct the thing. And with that, I will just run it, and we can actually have a look at the output. Hope that's visible. Let me try to zoom in a little bit more. So here it is. What I'm gonna do is just so we can go through. So the great thing about this is that it has basically the file name, the line name, and the function, right? So we can say line 74. So line 74 in my code. So this profiler, it takes almost 13 microseconds. So obviously we're doing it in microseconds here. And basically this particular piece of code runs in 13 microseconds. So this is the printing that RGC is 1, and then pausing, so because RGC is not 1, assigning that BR variable to this. So this branch is particularly expensive. So normally branches don't cost that much. This is just programs starting up, so you shouldn't worry about it too much. So the next thing is you have this starting profile, but this is not, because the scope ends here, the next function call is this do something. So do something does some particular manipulation with this break val, and returns a statement. So this is just literally a few, like 40, 400? No, 14 nanoseconds, and runs this particular code, returning it. So most likely, it's probably not going to be in line because I put the no in line. But as it runs, it prints its duration, its place from line and a function. And then following that, we have this main duration line 80. So now this profiler actually prints its timing, so which is about 2.3 microseconds, which is very interesting to me, where I will show you why exactly it's interesting to me. So the next thing is right here, line 85, this particular profiler, which takes about 750 nanoseconds, so 0.5 microseconds right here. Line 91, which is this profiler, which basically, as you can see, is just a constructor destructor, nothing else. And then we have line 90, so this profiler. So this profiler itself So it's profiling that profiler. How long does it take to construct and destruct a profile? It's trivial, right? And it takes about 2.3 microseconds, which is almost the same as actually calling this do something function. And there is a good reason for that, because here we're calling a function, and here we're calling the constructor and destructor, and we're measuring time to do that work. So as you can see, the printing statement, so this print, takes 0.75 microseconds. And so that time is also included into this printing plus the constructed destructor. So I think if you would just remove this printing itself from the destructor, we could actually see very different timing here. If it's called some other function where you just store these into async logger and then write to file or something like that, that will actually impact these times. So, and this is how you basically write a simple ad hoc profiler in your application. You can literally put in every single function that you have across your entire code base. It will also act as a sort of a trace. You can build tools on top of that. Given a thread, it basically tracks every function called and then calculates relative time that it took for its children rather than only itself. These sort of things can be done outside the application and basically for analysis later on, as you don't really have to do it while the application is run. So I hope that you like this little introduction of the tools that I generally use. These are not extensive. These are sort of introductory, and we will probably look at building a full logger and a profiler for any given application later on. And with that, I would want to say cheers, thanks for watching, enjoy your whiskey, and have fun writing fast code.